Okay, we're live. Hello, everyone. Thank you for joining us here today. And I'm here with Alexey Demedeckiy, who's gonna tell you all about using a graph system as encapsulation of global state. Please welcome.
Okay. Thanks, everyone. I'm gonna share my slides in a moment. Okay, I hope that everything is working and you can see my slides. So my talk today will be about graph system, what it is, how to use it, how we have come to it, and what is all the context about the graph system, why I believe you should care about it. So first of all, a little bit about me, for those of you who don't know me. I'm Alexey Demedeckiy. Currently, I'm a mobile architect at DraftKings. I help different teams to build iOS, Android for more than 10 years for now. This is mostly my main area of interest in commercial development in general. Last 5 years, I spent talking and teaching and practicing different versions of Redux and Flux architecture. They all can be generalized under unidirectional data-driven architectures. And last year, I have experimenting with graph system, and I want to share my experience with you. We launched a couple of production application with this, and more in pipeline of development. So I'm pretty happy with this approach, but we'll come to it. First of all, I want to share that everything that we will talk about will be around this small domain about movies and presenting movies to user. Why I choose the domain? Because some domains are more friendly to the graph system ideas. Some domains are more uh, didn't get any benefits from using it. Which domain friendly? It's this domain with a lot of entities where every entity has some connections to other entity, and you can represent the whole data as a graph, basically. If it's too sparse and not a lot of connections, then probably graph system will not help you. But before we go to the graph system, I want to put some context and discuss about state management timeline in general. From my experience, how I saw the state managed inside the application. It will cover MVC, family of architectures, different approach, including MVVM and all like Viper, all this kind of architectures. Then go to Redux, how selectors try to solve some Redux problems, and how graph systems is a generalization and continuing like abstraction of the graph system itself, of the selectors itself. Let's start with MVC. So first of all, what is the main derivative point for me about the MVC? It's that we have a lot of components where every component is self-sufficient, so it has its own state, its own like view model, its own view controller, its own set of operation, and some services are injected into it using some kind of dependency injection. But runtime state is isolated per component. This is the main for me principle of MVC family of architecture, where state is isolated in every component, and component is responsible for the state, actual information for the state, basically updating the state for keeping it in sync with the rest of the application. At this point, also, the MVC in general is shining because it's pretty much simple to understand on a global scope. If you look about the set of components, you have like set of components, nothing add, nothing to remove. It's nicely maintainable in terms of if you need to fix some component, you know that pretty much this component is like isolated, and any change that you will do in this component probably will not break any other component. There is no guarantee, but probably they will not break it. But it comes with the cons. First of all, it's a duplication of data and lack of consistency. What I mean on the duplication, that if we have the same entity represented in multiple controllers, it's very hard to keep track of mutation of these controllers. And so we end up with multiple copies, and we need somehow synchronize all between. Thus, we come to the problem of synchronization. For me, it's like main problem of MVC family of architecture, how to synchronize components between them. Because with growing of time, for example, in this example, let's imagine we want to add movies to favorite and remove them from favorite. So this is basic example, pretty much simple and relevant to every domain, every use case. You will need to introduce some kind of connection between these two models. And previously unconnected and isolated models suddenly become connected, which together. So it's meaning if something break in one model, the all relevant models will also be broken, and we want to avoid this. So the main problem of MVC, for me, it's a lack of common source of truth. There is no like there is no common like third-party arbiter who will tell what is true, what is it like actual information of the system. Everyone has its own view of the world, and this communication and try to agree what is true is big mess. And with growth application, it's hard to keep track, and we end up with a lot of patchy solution where we just spot the problem and add one additional thing between these two components because we spotted the show in the same data. But otherwise, we have no guarantees that we will show the same data across different components. Here comes Redux. So we know that after those years while Redux is on stage trying to to be sold to you by different teams, different people, different companies, that Redux shine in centralized state management. It was aimed to solve the whole this problem, like take all the state from all the components and move it to centralized place. So just make the place where all the state will live and make the third party arbiter who everyone else will be referenced to. So the state is like now a single place. We can keep track of it. We can verify that it's in correct shape. We can do all kind of stuff with the state, store it to the database or store it from the database, store it over the network, log for our purposes. But now the whole state of application is isolated, and everybody needs to rely on the state to do something. Let's look how the state usually is structured, because we will understand where the problem is coming from. State usually structured using something they call table-oriented design. So why it's called table? Because it's relative to the relational database structure and how relational databases are working. Mostly because of the same reason why relational database was burned, was arrived to. It's to guarantee that everything is pretty much consume the least amount of space, but in our case we want to guarantee that everything is in sync, so we don't have copies of our data across the system. That's why we model our system like a set of tables, like a set of different independent tables. For example, all movies, it's like a table for ID to some movie entity. All actors table from ID to some actor entity, and connection between them is done using IDs. So movie will not contain the copy of actor entity. It will contain ID or reference to the actor entity. And so with this spirit, we can organize pretty much everything. For example, list of top movies is basically a list of IDs, because movie can be changed from multiple places, and we don't want to store the actual movies inside the top list and top movies. We want to store only reference to them. So everything should be stored exactly one time and connected by references. In code, on code level, it's achieved like using structure where all like tables gather together in one structure, where every table is itself is just simple storage of something. For example, all movies contain single dictionary from the ID to the movie, and actors the same. Some contains just IDs without actual data itself. You can see that I use a lot of strong identifiers like ID unique to the movie or to the actor. This is done because we don't want to mix them up, because they often modeled like in the same type for the API side, but mentally like they mean completely different things. That's why you want to use the strong identifiers, and you want to introduce these IDs that will allow you to wrap simple values like strings or ints or something like this underneath the hood. Also, across the like centralized state, Redux is known for coordinated mutation. So it's the reason why we can guarantee that state will always be in the correct shape, and like without some transitional errors, because we change the state as a whole. Whenever change one portion of the state, we always change the state as a whole. So the new state will always be like result of the complete applying of the some action. That's why usually we put a store in between the state and just like move the old mutation to protected queue, dispatch queue, or to the some other kinds of protections we try to apply. So we build a facade around it. Also manage some kind of observer notifications, diffing if we need to, a lot of different duties, but logic is not in there. Logic and mutation is in state part. And mutation of the global state just usually implemented like as fun to those local states. So here we can see that state is mutated using Redux function, which just call other like components Redux functions as it is. From my experience, it's better never mix like aggregation components and logic components. Aggregation components is components which can contain other components, and logic is component which contains some actual reduce. So reduce for aggregation components will always pass action down the line. Reduce for aggregation for logic component will also switch by action type and try to change state in different shape. Redux itself has its own pros, and we know them very well. It's like consistency of the state in general, so we can rely on it, we can trust it. Transparency, who changed, because why something was changed, because everything has happened because of actions. There is no other way to mutate state. And isolation, using this database table design, we can achieve that a lot of small components are isolated, and if you want to change something, you don't touch the source code or other components. For example, new action or new reaction is required. You change only the component which is related to it. The cons is that we end up with a lot of fractured entities, and our mental model is not longer fit with our actual code structure. This is a problem because now we need to start thinking about the normalized state about from the business perspective, from the like a high level perspective. We are pushed very low to the implementation details, how the state is better to be mutated, how the state is better to be stored. So this all details of normalization and storing the data is actively infecting our understanding of how to use it. Let's see this problem on an example. First of all, let's try to access some information from this storage states that we just like implemented and fill the simple props. So this props for top movies view controller, it will show the set of movies with only two fields for every movie, like title and name of top actor for some reason. I don't know why. For those of you who don't know how the props work, it's basically like a view model for view controller, which can define the whole state of view controller at once, and it does not contain any behavior. So it's just the data. So structure, value type, which passes the data from the system to view controller. So basically, it's agreement or contract between the view controller and the rest of the system. So view controller should not have any link to the state, to the API services, all the stuff. It should use only the props. In this way, we can separate the view controller from the rest of the system and test system in separation and test view controller in separation using storybooks, using snapshot tests. A lot of techniques can be applied here, but this separation line is very useful. And if we'll try to route this like transformation from state to props, we call this transformation like connectors, the entities which help us to connect something to the state or to the store. We'll find out that basically you need to do a lot of tedious work to make it like done. First of all, it's like you need to access everything by ID, and the how things are stored inside the state are actively impacting the amount of code you need to write. You see a lot of like not very good science of code, so it's using IDs, it's the referencing, it's like force on ropes, because we hope that everything is like coordinated state. We cannot guarantee, and this code look a lot more complicated than it needs to be for the what it actually does, just projection from the some fields in the state or some fields to the props. It's very complicated. And this is the problem of Redux in general, that's a lack of common access interface. So Redux provides you a lot of means to protect your states, to protect your low-level implementation and synchronization of low-level primitives, but it doesn't provide you with any access interface how to access the state. That's why a lot of next generation state management tools was forked from the Redux, like Mobix, for example, which combine access patterns with internal reactive net of updates and allow you to have a nice interface, which is most selling point for a lot of people. First, the selectors were born almost at the same time as Redux to solve this issue. So selectors aim to solve this issue specifically. If we will look at using the state without the selectors, we'll see that controllers try to access state directly, and they need to duplicate all the access patterns they used to be. While introducing selectors is very simple set of functions that allow us to use the state from it. So let's look to how selectors is built. What is it actually? Usually it's just an extension to some states, to different level of states. Maybe top level extension, like give me top actor for some movie ID, or extension for more low level entities, like for actor, give me full name of this actor. So this is some portion of the logic being encapsulated inside the state. So it's some portion of access logic. And while we were trying to build this with a raw access state, if we go to selectors, it's pretty much the same, but much more cleaner. We have less use of ID, only where we need to. We basically can access full name without duplicating this logic all across the place. It's much better. So this is why selectors are pretty much first aid. If you're using the raw Redux state and complexity of the state is growing, you need to use selectors to some sort just to optimize usage, just to stop duplicating the logic between the screens, between the components, and so on. It's pretty much simple, isolated, but it has its own side effects, its own problems. First of all, it's just a function. It doesn't know any context. So you need to pass these IDs everywhere. And it's, from practice standpoint, it's never enough. So because you don't need to write them in advance, you end up in a situation when, do I need to write another selector, or can I just write code here, because probably nobody will ever use it. So you end up that code still lives in the connectors, and you need to refactor it later to selectors and when something is happening. That's why I see the main problem of selectors is a lack of structure. So it's present common access, but without any structure and any way to combine this to access, to make it more discoverable for users. And the final portion of my basically talk will be my journey. It's about graph systems. So in a graph system, it's evolution of selectors from my point of view. Where selector is just an extension that will use the state, the graph system is encapsulation that will hide the state completely. What is the graph system? Why it's called so? It's called so because it's tried to mimic the graphs that you know from the algorithms or from other fields. It's just try to represent the graphs of data inside your system. So literally, it's a graph with nodes and edges. Technically speaking, the graph itself is single value type with where it's wrapping the state itself. So that's just a value type that wrapping the state, nothing more. So no extra strings attached. And all the magic is happening inside the extensions. So for example, we want to have a movie, like a node in our graph. That's why inside the graph, we create extension for movie. And it's a nice agreement that every node have a link to a graph, just for the sake of, traversing to other movies and having access to the same state all the time. So movie have access to the graph. Movie has some understanding of its position or coordinates or ID. Sometimes it's ID, sometimes it's index in a table. So it's some kind of like GPS coordinates of this entity inside the state, and then set of accessors, like the title. It's an accessor with just projected from the graph, nothing extra created here. And other hands, how to access this movie. The graph can provide you the entry point, top movies. Top movies is like just a map from IDs from the state to the movie entity inside the graph, but it's important because it's like it give you another node in the graph, so you're always traversing inside the graph. Of course, you cannot have graph without edges, so edge is just link that will give you another node in the graph. So for example, for movie, we can have edge that will deliver to all actors. All actors, it's also a node in the graph. So as you can see, I returning graph.actor, which means it's node. And graph can have link to movies because everything, it's all this, like it's computer properties where it's created on the fly. We can have cycles without worrying about memory management. So it's like cycles on top of nicely structured value type underneath of it. I think it's pretty neat because you usually don't do not allow to use cycles with like structures because they will tend to have an infinite amount of memory. Let's look how selectors, how our connector looks with selector. So basically, it's the same. Somewhere we have IDs, somewhere we don't. But with a graph system, we can express directly what we need and what we want in like our code, because graph system hides and encapsulates all access details while allow you to build any interface that you want to expose to your end users. So you even can have multiple interfaces for different use cases. Somewhere it will be just a list of top actors, for example, or top actor will be just property of a movie if you often need to access it. So you're free to build whatever interface you want and let your users, let your components use this handcrafted interface that is tailored to the domain model, to the mental model of the problem itself, not to the technical implementation, how it's better to store and to manage it. And if you can see, the graph system itself allow you to have some cycles. Again, the reason why we can have cycles, because we don't store any actual data. Graph system always act as a projection from the state to the values we want, not a storage level. So graph in the same way, it's a free, without side effects, without even data itself. It's just a set of functions organized inside a graph. Another beautiful topic of graph system is how we can incorporate mutation inside the graph. If we add second property to our graph, like dispatch, it's a function that will take the action, basically. Then we can write functions on top of our entities. For example, in a movie, we can add extensions that movie can be watched. So I want to watch a movie, so dispatch toggle watch. Here it goes. You dispatch what action you need to toggle. While ID is still like hidden inside of a graph. So ID never leaks to the outer world, to the consumer. So consumer just tell, I want this movie, I want to watch it, and it's okay. It's the same as goes with unwatch. So graph has preference, like pros, that it's direct mental model mapping for me, and IDE is super helpful because it's a very small interface. I can explore my graph, I can explore my domain using the IDE. So because I don't need to type any new like types, I always inside the same like autocomplete chain, if you want. So it's graph.something.something. But the cons is obviously that we need to write more code. Again, it's a little bit verbose because it creates the same set of entities but on a different perspective with slightly modification. And if your domain is simple, the difference between two may seem like neglectable. So you think, I will use state directly. But with growth, with more and more time and effort put inside the application, the graph and the state underneath it, they evolve using different paths. So more logic is stored inside the graph. and less the state itself less suited for direct use. At this point, usually I go to the questions, and the first question that everybody asks, like, is it like ORM on site the invented or write it from scratch? And I will answer that yes, it is. The same way we can treat our Redux centralized storage like in-memory database, we can treat graph system like some kind of ORM on top of this database. The same principles applied, but it's much, much simpler. So usually ORM is all about optimizing and fetching data preemptively because access data is like it's a costly operation. Here, it's just an abstraction bump because access data costs the same like accessing directly. It's already in memory. So it's only about the memory management. And at this point, we can go to the answering the questions. If you have them, you can write it to my mail. You can follow me on Twitter and ask there. Usually, I wrote a lot about different stuff like Redux, now graph systems. We're trying to find a better way to write applications to maintain them without like requiring too much effort from everyone. I think that's it. I'm 3 minutes to my like deadline, so we can go and process as much question as we have.
Thank you very much. It was a great talk. I've learned a bunch of new terms for me, and I got like a bunch of new ideas on how on the ways my current approach in my current applications is bad. Now I need to fix it.
Yeah.
Okay, I don't see any questions in the Q&A tag, but there are some activity in the chat.
Okay.
And yeah, we have a question. With the graph solution, don't you simply implement an object model here like core data, except your data is not persistent?
Yeah, nice question. That partially touched the like symmetries with core data. So what is a let's say it this way. The problem with core data that you need to it's mutated without coordination. Yeah, so it's not mutated across two actions. I cannot write reducer for every node model. So it's basically very heavy lifting. For testing, I need to create special like context. So it's heavy lifting approach, which allow you some kind of persistency. Yes, of course. But for me, it's look like heavy lifting. It's more runtime performance. It's questionable because here I deal with raw data and memory, so I can we measured so it's hundreds of thousands of actions per second. So it's a huge amount of stuff you can process using the Redux. And in the large applications, I mean, not simple to do counter, but in a large application, huge amount of stuff can be processed. With the core data, you need to think about optimization pretty much in a middle level of. So when you have like 50,000 of entries, you already need to think about optimizing what to load, what to not load to the memory, and so on and so forth, because of footprint of that core data is adding to you.
What do you prefer, like, for implementing such an approach? Like there is, I think the current React things is gonna fit pretty nicely.
So on UI level, anything will work. So we have the front ends with UI kit, with Swift UI. It's all the same. We have front ends with a like it's cross-platform approach in some sense because we use the same like techniques on iOS and Android, and we're moving into trying to have a Kotlin multi-platform version of it and try to play with it. Just because it's just logic, so we can pack all the graph, all the core to the Kotlin multi-platform and just write UI on each level for it.
As a matter of fact, on my main project, I guess, like on my job, we recently moved to Kotlin. We started moving some logic to Kotlin multi-platform, and I discovered that it's a huge pain to integrate it into iOS because in Android that's easy, but it came as a big surprise that Kotlin multiplatform classes, they're not going to be Swift classes. They're going to be like Kotlin int, Kotlin double, stuff like that. So I was wondering, what are you going to use to implement such a logic on the Kotlin multiplatform side?
So it's an open question for now. We're running different proof of concepts because we need to migrate a lot of stuff. I mean, graph system is just one component of a production like data-driven application. We also need to think how to migrate our side effects, how to migrate different APIs, and so on and so far. But in the end, I think we will need to adapt to some form of code generation to provide nice interface for the Swift, because the beautiful interface is, from my perspective, from my like beliefs, beautiful API, beautiful interface, beautiful design is what separate like pleasant day-to-day work with the system from the day-to-day pain with work in the system. So you need to invest into usable interfaces. You need to invest into something understandable intuitively by the developer. So it should be relatively easy. Just pick something and create something new, because otherwise you will need to have much more skilled engineers, and investment inside the engineers are much more risky than investments into API, because API will never change the company. They will always be with you.
And the API will get depressed if it had to work with some weird code, right?
Yeah, exactly.
Cool. I'm thinking, yeah, I guess we don't have any more questions. So I'm going to ask the last question, like from myself. It's not exactly on the topic, but you mentioned the code generation for such a feature. And how are you planning to tackle that? Because it does seem like a lot of work, and you have to think about the interface, not just replacing the classes and generating some interface. Like, that's going to be super tricky, especially with the graph system.
Actually, no. I use code generation in different forms for a lot, like API contracts, analytic events, tests a little bit when you can. So a lot of stuff can be code generated. But if you will go to your own in-house code generation, because what it is code generation to like, it's the program that have input in form of some, I don't know, JSON, YAML, whatever, and it produces some output in the form of text or file. So writing a program that produce text file as you like it, it's pretty much the simplest task of it. Preparing the inputs for this program may be tricky, but in the end, you can have the repo with JSONs or YAMLs, which is edited by hand, and then you use simple programs using Swift. Any language basically will work, because it's just a text generation from the input. So anybody can write such programs, until you go to the huge solutions, which has its own like pros and cons, which has its own like set of interfaces which you need to adapt to. Then it's become complex, because you rely on huge amount of code that somebody else has written for you. But if you will do it for yourself, it will be damn simple, because it will solve one problem, and solving one problem is always simpler than solving all the problems at once. That's why code generation, it's easy part of the stuff. You need to access data, you need to transfer data to something else.
Oh, yeah, I think I got it. Thank you very much.
Yeah, you're
Thank you
welcome.
very much for being here today with us. Thank you everyone for listening. And we are going to have a short break. And then there's going to be a panel discussion on mobile app testing and doesn't matter on Android track. Please don't forget to rate the talks you see, especially this one. I'm going to go there right now and hit a 5-star mark. That's for sure. Please also keep in mind that there's going to be a giveaway on our sponsors panel, or like part. There are going to be prizes anyway. And this spatial chat is open, so you're welcome to ask a lot of questions and communicate and stuff. Well, thank you. Have a great the rest of the conference.
Have a nice
Bye-bye.
day. Yeah.
Okay, the stream is ending, so I better not do any weird things
Okay,
while it's counting down.
don't break it down.
Bye-bye.